What's up, guys? Ian Sandusky from Lakewood Machine & Tool back here again for Practical Machinist, and we are live from day 2 of IMTS here in Chicago. And right now, I'm joined by my friend Brian from Phillips.
How you doing, Ian?
How's the show been so far?
It's been great. We've had a lot of activity in the Meltio booth where we have our Phillips hybrid machine.
Now, this is something that is familiar to me because it's a HAAS and it looks like a mill, but I see some things that I am not so familiar with. First of all, we have a cover on this screen, and that's because of that thing right there. What am I looking at?
So that is Meltio's deployment mechanism. So we have Meltio's laser welding head that's mounted to the side of the HAAS machine, but to protect it when we're machining, the head will actually retract up into the deployment mechanism, trap doors will close, and protect it from coolant, chips, swarf.
Because right beside that, that is a standard spindle mast, I guess you want to call it. This is the Meltio add-on.
That's correct.
And when we're talking about the Meltio, what is that doing? I mean, it's 3D printing, but what kind of technology are we seeing here?
So at its core, we're laser welding. With Meltio's technology, it's a center-fed wire with 6 independent lasers surrounding that wire. So what we do is create a hexagonal melt pool with the wire in the center. So that allows us to feed in any direction. Because you have lasers in the front, back, and sides, there's no restriction in terms of feeding in X positive, X minus, or a combination of XY motion. We can also do 5-axis deposition as well.
Because as you can see in there, that is a 5-axis machine. That's on a trunnion, so that can go from literally any angle.
Right.
So it's a lot like, for guys who may be more familiar with something like a MIG, where the wire is fed, but you have that tack that actually can melt it from all sides.
Right.
Now, I have a feeling that's just not regular MIG wire, is it? What kind of material are we doing right now?
It actually is. You know, it's 100%, commercially available MIG wire. So the wire spool is actually in the cabinet on this system. It's 30-pound spools of 316L stainless. We can do a lot of different materials, across the stainless portfolio, 17.4, 308, 316, as we're printing today, as well as a bunch of other materials like mild steel, titanium, nickel-based alloys, and tool steels.
So what makes this really special, since that's 316, is you are getting the print out of 316, but because this is inside a mill, it looks like you've already done a milling operation all in the same machine. Now, do you need to do anything special between operations there, or? So
with stainless, we can water quench. The reason why we machine the bottom of this part, we can use a much shorter end mill in this case and not have to worry about clearances with this kind of shape.
Right.
So we can machine it much faster because of the rigidity of the tool. Also, cost of tooling is much less. We don't need a lot of specialty items. So we'll machine around the outside, deck the top, run a little corner rounder around the outside of it, and then start printing this spine slice on top of it.
Oh, so you did actually run that just looks like a nice part because you have that nice radius right around the outside. Now, can you only do one kind of material in this at a time?
We can actually do dual material. So if you had a part where you wanted to clad, let's say maybe there was some corrosion requirement, you could print a layer of Inconel on the outside of this part and then machine that. So you could use a cheaper material to build the bulk of the mass and then print your more expensive or more difficult to machine materials just where you need it.
And that's literally the only way you could do that. I can't even think unless you're inserting, and then if you're cladding it, it's literally part of the same grain structure in the material.
Exactly.
It means it's stronger, it's cheaper. And what kind of companies are you seeing do this kind of technology right now?
So we're working with a lot of large OEMs. They haven't, gone in and purchased systems, but we're doing a lot of their applications. So a lot of feature addition where you can start out with, let's say a 3-inch diameter shaft, print a ring or a boss on one area of that part, print it, machine it, and you can save, having to start out with a 5-inch or larger diameter bar stock.
Huge. I mean,
so time savings and material cost.
And that really adds up. But I mean, 3D printing, it's got a reputation of being a little difficult to get into. It's a little intimidating historically. And of course, it takes time. What kind of cost in terms of material are we looking at this? Because I think people are going to be shocked.
Yeah, because we're just using commercially available MIG wire, you're talking about $20 worth of stainless material. The argon, our flow rate, 15 liters per minute is, a little bit higher than a conventional TIG or MIG process, but we're getting, tanks of argon that, 300 cubic foot tank for about $52, and we're going through a tank every 14 hours.
Which is not that bad at all.
No, argon consumption is really not a concern in terms of price of the part.
We're not talking about $1,000 in print costs for the customer. Obviously you can figure out your bill rate and everything on top of that, but it really is accessible. Now if we want to take a quick look at the actual control for this here, so we have our CNC mill controls, very standard. What are we looking at here? I imagine this is the actual control panel for this.
So this is the Meltio controller. At the end of the day, all your code is running off the HAAS. So G-code program has your M codes that communicate with the Meltio controller. So we have 8 signals, which are all tied to the HAAS 8 M code board. So we can do things like deploy the head, retract the head, turn on shielding gas, and then obviously the laser on and off command. So with these signals, we can actually have our own G-code and subroutines for each signal for dwell times, changing power. So like you want to have a higher laser power when you start, and then dialing back the power when you actually pull the wire out of the melt pool. So when you stop, you can have a much lower laser power at that point. So we can tune all these macros per material, which allows us to really fine tune kind of the prints, as well as monitor. So what we have down here is a load cell. So this is tied to the emergency stop circuit of the HAAS machine. If we see a violation of what our maximum load is on the head, it'll automatically stop the whole process. So if your wire were to get stuck because you're doing process development and then it goes to rapid, it'll tug on that head and automatically e-stop both systems.
So it protects not only the machine itself, but the whole unit as well.
Exactly.
Now, this kind of system here looks pretty intimidating. How quick are you seeing guys getting started with this kind of system who are maybe not familiar with this?
Sure, when we talk about the customers that we've trained, a lot of guys have been machinists, no CAM software, a very easy learning curve. You're talking about an additional couple of toolpaths that you need to know, and then the Meltio control. So the control does look a little bit daunting, but it's really just a lot of display. So, laser power, what my actual feed rate of the wire is, gas flow rate, and then some manual functionality where I can deploy the head, retract the head. So we get guys up to speed within a couple of days running the systems.
Because when I was seeing over there, you don't need a special unique CAM package in order to program this. If I'm correct, this actually is a plugin for Mastercam.
Yeah, so we use Mastercam A+, to program this part, where Mastercam is kind of the generic platform that we're using, but then A+ has developed the additive toolpath, and they have about 7 or 8 different additive specific toolpaths that we use in conjunction with the subtractive side of Mastercam. So it's a complete seamless process where we can have machining, additive, all inside of our operations manager, post it out with one post processor, and run the G-code.
It's absolutely crazy. If we want to look back in here one more time, I want to show this part going. You can see on the one side of the table there, that's that part that we're running right there for a secondary operation. And then for the first one here, that is actually doing the laser deposition right here live at the show.
Right.
So after this process here, what's the next operation it's going to do?
So it's going to continue to build the spine slice. Then it'll do some simultaneous 5-axis deposition due to this 45-degree overhang. That way the print head is always normal as it rotates around. It'll go back to do a positional 3+2 operation to print up the boss. It'll go in, machine it, both the OD and ID inside the counter bore. Then we're going to flip it 90, do the engraving for the part number, and then we'll part it off and tab it with a high feed mill. So we'll take a 1/4 inch high feed mill, go back and forth, leave about 1/8 of an inch, snap it off when it's all said and done, and then it goes into the second op fixture, and we get a complete part every cycle.
So literally, I didn't realize you were tabbing this off. Not only is it 3D printed, you literally grab this off at the end, and I imagine all you're doing on that last op there is just cleaning off those tabs. That is really, really fast. Just so people understand kind of what our cycle time in here, I know you have some op stops in here for safety and just while we're at the show. What is the total cycle time for a part like this?
That cycle time is 3 hours, 20 minutes. We're about 3 hours worth of deposition and maybe 15 minutes of actual machining time.
And the machining time is laser quick, and this as well is very, very fast. And as you mentioned, when that does go to mill, you can see it almost has a couple of doors there. That pulls up to try to protect that from coolant and all the chips. Well, this is absolutely fascinating. If you're coming to IMTS, I highly recommend you come check this out. There are tons of people around right now fighting to come take a look at this. Make sure you come check out Phillips and the Meltio. Thank you very much for your time today.
Thank you, Ann.
Where can they find you online?
So we can come visit us at Phillips Corporation on our website. We're also on Facebook and on a bunch of social media.
Excellent. You guys take care.